I'll start right in. Pleiades is a community-built gazetteer and graph of ancient places. It was built using the Plone content management system, which is why we're here. It publishes authoritative information about ancient places and spaces, providing services for finding, displaying, and reusing that information under open license. And we publish not just for individual human users, but also for search engines and for the widening array of computational research and visualization tools that support humanities teaching and research. Pleiades was incubated during the early years of this century in reaction to two related developments. First, the year 2000 saw the completion of a 12-year, multi-million-dollar project to compile and publish a comprehensive atlas of the Greek and Roman world. This thing right here. It's from that classical atlas project that Pleiades takes its name. In Greek mythology, the Pleiades are the daughters of the Titan Atlas. It's hard to believe, but this project, which was chartered by the North American Society for Classical Studies and funded through a combination of private and public funds, was the first project to successfully bring such an atlas to print since 1874. That time lag provides a critical insight into why academic classicists took on such a challenge. Not only had a century of literary and historical research gone by, but the entire modern discipline of archaeology had been born, had matured, and had brought massive change, both factual and theoretical. And this insight dovetails with the second reason we dreamed up Pleiades. The period of the atlas's creation coincided with, to a significant degree, with the maturation of desktop geographic information systems and the dawn of the geographic web. The project was really hybrid because it started before using full up digital tools was really in prospect. But as we went along, the professional cartographic shop that supported the Atlas project brought more and more GIS into the production project. But it was still, in the end, a cartographic art project that produced a print item. Bringing Pleiades to life, so the next generation took a bit longer. We wanted to bring all the data that had been assembled for the Atlas into the modern world, if you will. And our first attempt to obtain funds was not successful. We were calling the thing an Internet Archive for Ancient Geography. The major complaint we ran into with one of the proposal reviewers was that we had not pre-selected whatever combination of workflow engine, content management system, wiki system, web framework, or databases that we were going to use to build the prototype. Keep in mind, this was 2004. So Wikipedia is a relatively recent development. I think Google Earth was about to hit, but had not actually sprung on the scene yet. So that's kind of the lay of the land. We had been hoping to use grant funds to hire a developer to work with the project team in making our technical stack selection. But in light of getting shot down in the review process, we decided to work in our spare time to do some initial evaluation before submitting a revised proposal in 2005. So it's then that we chose Zopen Plone. Why, you ask? Well, I have to confess that one key reason was one zip file to download, one click install story. We were up and running with a toy environment in mere minutes. We didn't have to prove our Java wizardhood. We didn't have to present any credentials. We were not in any kind of dependency management purgatory. At least we weren't aware that we were. We didn't have, operating system incompatibilities. Plone just worked. It checked our other boxes too. In particular, customizable workflow rules, customizable content items, a template framework with skin abstraction layers for the UI, all that sort of stuff. I'd be remiss if I didn't mention here that we had some helpful advice during this period by a guy named Chris Calloway, who I think is attending the conference this year. So shout out to him. And so by 2006, we were launched. Our first grant provided by the U.S. National Endowment for the Humanities allowed us to hire Sean Gillis as full-time project developer. Sean was to stay with Pleiades in the capacity of chief engineer until 2013, helping us with a series of project milestones, including 2 subsequent NEH grants, the transfer of Pleiades headquarters to New York University in 2008. It had been at the University of North Carolina at Chapel Hill before that, and crucially, our transition to full production status in 2010. So we're not only grateful to Sean for his role in these core project achievements, but we're proud that NEH and ISOF funds were able to support his early work on the Python Shapely package for manipulation and analysis of geometric objects in the Cartesian plane, and on the GeoJSON format specification, which has subsequently matured into an internet RFC. In the 7 years since Sean left NYU to work for Mapbox.com, we've come to rely on the development team of Jazkarta Incorporated for Plone maintenance, upgrade, customization, and cleaning up the messes that I make when I fiddle with code. Our most recent NEH grant, which began in 2016 and ended a little over a year ago, allowed us to address a number of growing pains that had built up over time and turned into major impediments. The biggest change came early in that process, early in 2016, when Jazkarta helped us upgrade from Plone 3 to Plone 4.3 and to rehost to a more capable server managed by our longtime hosting provider, Tummy.com. Jazkarta took this opportunity to systematize our deployments using Ansible and to install New Relic monitoring to identify and address performance bottlenecks. All this was a non-trivial exercise. I think Alec may be forced by my having mentioned it to explain that in a few minutes. And one of the main reasons I think he'll touch on is that we have such a large amount of customizations we're carrying in our software stack. That whole process was worth it, though, because we very quickly saw year-over-year improvement in average page load times of nearly 75%, which was down from a painfully long average of 12 seconds to about 3 seconds. Now, standard deviation on both of those is pretty wide, given our global user base and some of our folks being in places where they have metered connections and slow connect times, but still really big improvement, and most of our users see very fast performance. Subsequent work has improved things even further, such that I don't think we've had a user complaint about performance in nearly 3 years, even though we've had some big increases in content complexity and so on. So what I'd like to do at this point is switch over and do a demo. So we're gonna grab the browser, whoops. So this is the Pleiades homepage. What's in Pleiades? Let's get some orientation here. Since we call ourselves a digital gazetteer of ancient places, I think the easiest thing to do is to pick a well-known place and start there. How about the city of Rome? Looks like Pleiades knows about 4 places that begin with that string R-O-M-E, and the first one is the one we're looking for. So here we're looking at the Pleiades entry for the ancient settlement of Rome. I'll scroll down so you can see the map and confirm that it's where it's supposed to be. This is an HTML view of an instance of a custom Plone content type that we call a place resource. Our content types are presently still built on archetypes, and you'll recognize at the top of this view some of the standard Dublin core fields like title, creators, contributors, a rights statement, last modified date, and summary. I'm going to blow this up just a little bit for folks with small devices. In Pleiades, our place resources are the primary organizational construct of the whole digital gazetteer. They're conceptual entities. So we apply the term place to any locus of human attention, material or intellectual, in a real-world geographic context. So a settlement that's mentioned in an ancient text is a place, whether or not it can be located now. An archaeological site is a place. A modern city located atop an ancient settlement is a place. If you and I both had access to time machines and we could find a way to agree on somewhere to meet for lunch in antiquity, that would be a place for Pleiades purposes. So basically any spatial feature that's connected to the pre-modern past and that a human being has noticed and discussed as such sometime between the past and the present, that's a place. If we look at what's here on our view, this canonical URI business, this simply repeats the stable uniform resource identifier that Pleiades automatically assigned when the content item is created. That's there in your browser location bar. We repeat it in the view and provide a handy JavaScript copy to clipboard affordance in the UI because the assignment, stability, and reuse of these URIs constitute one of the most important functions of the gazetteer. Especially in the early days of the project, most humanities scholars were unaware of and suspicious of the web's long-term reliability for scholarly publication purposes. Bitrot was, or link rot was a huge problem from an academic perspective because we want to cite everything. We want to be able to find out where assertions about the things we study came from. So we provide a unique stable identifier for places in the ancient world that other scholars and students want to discuss or reference in their own publications and data sets. And as a result, over the last 10 years, these URIs have come to be used in a variety of other web applications and research data sets. So that makes it easier for scholars and students to combine multiple data sets that they gather from different places, different repositories, and use them for research tasks without having to clean or align all the geography by hand. So that's one of the important things we do. This representative point here, this latitude longitude value, is calculated automatically. It's usually a centroid of whatever spatial geometries are associated with the place. We'll talk about more of that in a minute. And first, I want to look at a slide and talk a little more about our custom content. Not Sean and Scotty, but custom content types in Pleiades. So the place resources, like the Rome entry we've been looking at, are folderish, as the Plone folks say. That means they can contain other content. In Pleiades, we allow only 3 other custom content types inside places. We call these locations, names, and connections. And there you get recent counts of each. I think if we move to another famous ancient city, we can have a good look at those. So let's go here. So welcome to the ancient city of Nineveh. I'll let you watch the map. It's located near the modern city of Mosul in Iraq. In this place resource, you'll see we've defined 2 location resources right here. We use locations to store the geospatial information about where an ancient place may have been located on the Earth's surface. Both of these are depicted on the map using the color blue. One of these is a simple point geometry imported from another database or data set called DARE, which stands for the Digital Atlas of the Roman Empire. It's the work of Johann Elfelt at the University of Gothenburg in Sweden. The second location is a polygon, and it's derived from OpenStreetMap, from a way or a relation in OpenStreetMap, and it corresponds in this case to the boundaries of the modern archaeological site. So let's look at our location here. If we take a peek at it, you can see we store more than just the spatial geometry, although that's really obvious in the case of a polygon. We can subtype our locations. Here we call it a settlement because that's what we're outlining. We might have called this an archaeological site instead, but in any case, that's the current state of the data. We can indicate the nature and extent of archaeological remains associated with the location. This is of value to cultural heritage organizations, NGOs that respond to disasters, organizations that are engaged in the protection of cultural property during conflict, that sort of thing. Knowing whether the thing is visible or not, and if there's something substantive on the surface is very important. We can also signal our confidence in associating this particular location with the place and any of the other information like names and connections that the place contains. Another crucial bit of information that we store is a citation. In this case, it's an annotated link to the OpenStreetMap way in question, the one that we imported to create this location. And keeping this information does 2 things for us. Firstly, it allows us to credit OpenStreetMap in compliance with their data license, and it also makes it possible for users to inspect the original data source in order to evaluate for themselves its quality and relevance. So the place resource for Nineveh also contains a number of name resources. In Pleiades, name resources store information about toponyms, both ancient and modern, as they're associated with a given place. Pleiades names are more than labels, and therefore they are a more complex content type than a simple string or a series of language encoded strings. So if we look, for example, at the Pleiades resource for the ancient Greek name of Nineveh, Ninos, you can see that we record one or more romanization forms. Romanization forms are transcriptions in Roman characters of the ancient name. For some languages and writing systems like Polytonic Ancient Greek, which is what we have here, and modern or historical Arabic, multiple romanization forms can and probably should be used for the same original name. We want them to be used because we want our name-based search to be as easy and effective as possible. Regardless of where you're coming from with a particular variant on a name, we want you to be able to find it. So we're encouraging our content contributors to provide as many romanization forms as are commonly in use or that one finds in earlier scholarly literature. When the original writing system is fully and accurately represented in Unicode, we fill out this attested name field, and then additional attributes are available to indicate the language and writing system of the original, to indicate the function of the name in the original context, and to characterize the accuracy and completeness of the text or texts that have communicated it to us. The next thing we encounter in the HTML place view are two clickable lists of what we call connections. We use connection resources to express direct place-to-place relationships. They enable us to document geographic, political, and analytic hierarchies, networks, and linkages. Although the basic functionality for connections was introduced into Pleiades years ago by Sean Gillis, connections in their full current form are relatively recent implementations. So Alec Mitchell and his colleagues at Jazkarta bear the scars of turning these into full-fledged, awesome things that we have today. So connections as we have them now turn Pleiades into a directed graph. Our place resources are nodes in the graph, and the connections are the edges. Consequently, any place can participate in an ordered pair as either the origin, or you can call it the subject if you like RDF parlance. So it's either the origin or subject, or it's the target or predicate. And that's why you see two lists of connections in the place view. Makes connections with, list connections for which Nineveh is the origin. So Nineveh is a part of whatever. The receives connections from list shows connections in which Nineveh is the target or the predicate. So the Handuru gate is part of the topographic area of Nineveh. Let's look at one of these. When you examine a connection resource in Pleiades, like this one, for the administrative relationship between Nineveh and the ancient kingdom of Assyria, it becomes immediately apparent that our graph's edges are not simple. They're attributed, just like the nodes are, the places. Apart from the connection type, our contributors can also indicate scholarly confidence in making the connection, the time periods during which the connection is thought to have been active or functional, and any references to scholarly literature, databases, or websites that provide evidence of it or information about that connection. These three attributes, association certainty, temporal attestation, and the references down here, they're provisioned not just for connections, but also for our names and locations. So you may have noticed them in the HTML views we looked at earlier, even though I didn't mention them. These two temporal constraint attributes, not before and not after, are a recent addition to the data model, and they apply to connections only. They were requested repeatedly and loudly by our users so that events and durations, when there's good historical data for them, can be more precisely delineated. So although these attributes are not extensively used on this particular connection, you can see them hard at work elsewhere in our data set. References are not limited to locations, names, and connections. We use them extensively at the place level as well. Nineveh boasts a substantial number of them, more than average in the data set. Our goal with references is to connect users as quickly as possible with additional information about the resource in question. Whether that is because the item was used in developing what we're showing you in the place resource, or if it provides additional information that might be useful to you, or more data of some kind. So we link to things like photograph collections and that museum sites and that sort of thing. We focus on getting users to the resource in question as fast as possible. So if the thing is available online, we're going to link right to it, in this case to a site called Topos Texts that was created by a guy named Brady Kisling. It has cool stuff like lots of ancient source citations in which a particular place is mentioned. But if the item is not online, but it can be found separately cataloged in libraries, we link to the corresponding entry in something called WorldCat, which is an online union catalog of academic libraries around the world. It's maintained by the nonprofit Online Computer Library Center, or OCLC for short. And by linking to WorldCat, we make it easier for users to identify the nearest library that holds a copy of the work that they're looking for. That apparently is not a valid zip code in the US, but never mind. For journal articles and other works that are not cataloged by third parties, we're going to link to our own geographic database. We use the open source Zotero citation management system for creating and managing all of the bibliographic data that we use in our references. But we only link directly to the Zotero record when we've really got no place better to send people. Zotero is run by the nonprofit Corporation for Digital Scholarship. It has a robust and reliable API that we use at author time. And we use it to relieve our contributors from tedious 20th century style bibliographic formatting tasks. And if I don't run out of time, I think I'm doing okay. We'll see it in action in a minute. You'll notice above the reference listing that we have a place type attribute. We've been looking at settlements so far, but Pleiades gives us the ability to describe many more types of ancient places and spaces. So let's see that in action real quick. All of the place types in our controlled vocabulary are listed in our advanced search on the categories tab. You can see we've got a bunch of them. Let's look at lighthouses. We can use that to quickly find things, and I want to limit our results to places. I don't think I'm logged in, so we'll only get published items regardless of what we ask for. Yeah, so here's 8 lighthouses that are indicated as such. This one is the famous lighthouse of ancient Alexandria on the Egyptian coast. It's one of the original 7 wonders of the ancient world. So this lighthouse was super famous in antiquity. In fact, that it was simply known as the lighthouse, Pharos in ancient Greek. So let's return to the advanced search. I could demonstrate another key aspect of the data contained in Pleiades. Go back to the categorization tab. There's a lot of places in the ancient world that are mentioned in historical texts that we can't locate today with any kind of precision. Pleiades records these as well, and we normally add a place type value of unlocated to the corresponding resources. And that lets us hunt for them in the advanced search. You'll see we have just a few unlocated places. Let's narrow it down to unlocated places that have been added recently. Here's a few. The funerary grove of Epicrates sounds interesting. Right, so typical of unlocated places in Pleiades, you'll see that no locations have been recorded. We do, however, have some connections that are used to provide associations with other geographic features known to be associated with this one on the basis of ancient sources. Nacrason is interesting because it's not precisely located either, but scholars have theories about where it was. In fact, you can find 3 competing identifications in the scholarly literature. So these are archaeological sites that are in the right general area, but there's no definitive evidence to say which one was this one named Nacrason that shows up in some ancient texts. So you'll see that we have 3 discrete locations associated with this place resource, and each of them makes use of the association certainty attribute to indicate the tentative nature of the association. And if you look at the map, you'll see each one of these is represented with one of our blue crosshair icons, which is the point location. So now I'm going to talk briefly about this representative point in more detail. It's indicated on the map with an orange circle icon. We've already noted its presence in the textual form in the attributes listing. In Pleiades, representative points are calculated as an approximate centroid of the locations associated with the place resource in question. Those of you who are familiar with the Python Shapely library will recognize the terminology representative point. It's not always a centroid, but it often is. So in cases like this, the representative point will fall somewhere between the various location geometries. In similar cases like Rome, Nineveh, and the Pharos, they'll fall near the center of the locations. We've also discovered that there are times when we know where a feature is, but we don't want to use a location for it. What do we do about the representative point then? And why would we want to leave locations out in the first place? Well, big, complex, broad features are a good case study. Let's consider Hadrian's Wall. There it is. So what's going on in the map here? We're visualizing 2 things for this huge complex fortification system. The spatial coordinates of each of the connected places that together constitute the fortification system. So these are the green bow tie icons that are all stuffed in here. And this time, the orange circle denoting the wall's representative point is calculated on the basis of those geometries, since we don't have any location objects defined on the wall place resource itself. We're starting to use this technique with kingdoms, provinces, and other administrative and regional divisions as well. So here, for example, is the island of Sicily. All right. It was also a Roman province. And it's here that the GIS folks are usually going to say, hey, why don't you just do a spatial containment or an intersection query instead of messing around with all these connections? That seems like a ridiculous amount of work. And I'll give you 2 interrelated reasons. We're not just making a map or constructing a geospatial data set for spatial analysis and cartographic visualization. We're creating a data set that could be used for lots of tasks in addition to those. We want a data model in which every place known to be in a province, let's say, is properly associated with that province. A pure spatial query isn't going to find the unlocated places. Moreover, ancient regions and administrative divisions are and were sparse in spatial terms. We may know lots of settlements on a particular area of the Earth's surface, but we may only know about the belongingness of some of them to a particular historical region or administrative division. And moreover, we'd be making a huge error by assuming that ancient administrative regions were solid polygons in the first place. Borders could be fluid or ill-defined in real fact, and the internals could look like Swiss cheese if all the borders were, even if the borders were precisely defined and you could map them accurately, which we usually can't. Let's consider, for example, Delphi. This is a famous ancient sanctuary of Apollo in Greece. Delphi wasn't just a bunch of temples. It controlled a significant land area and therefore had an important economic role in the region, above and beyond its religious and diplomatic functions. A naive observer would assume that during the Roman imperial period, this site would have fallen within the Roman province of Achaia, but legal documents demonstrate that Delphi, in fact, had a direct bilateral relationship with the emperors, and it so bypassed the provincial administration completely. The Roman governor of Achaia could say nothing legal about what went on in Delphi or involving Delphi's neighbors, even though he had authority over the neighboring communities. Delphi gives us a chance to talk briefly about another important aspect of Pleiades places. We call them alternate serializations or alternate representations. So far, I've been showing you the HTML versions of the content in the Pleiades ZOP database. Those of you familiar with how Plone 3 and Plone 4 work will recognize the term base view. When you look at Pleiades places, names, locations, and connections in a web browser, you're looking at rendered versions of a customized Plone HTML base view template. Those of you who program Plone will know that it's possible to create alternative views for content items, and that's what we've done. You'll see the links on every place page under the heading Alternate Representations. Clicking on any of these links, I'm going to click on JSON, will get you the corresponding format, complete with the appropriate MIME type and the response header so that your browser can try to figure out what to do with it. Here, for example, is the JavaScript object notation serialization of the Pleiades place resource for Delphi. Not going to click on it now for time reasons, but you can click on the KML link to get a keyhole markup language serialization. And if you've got Google Earth installed, and if your browser knows about it, and if you don't have an old version of Adobe Photoshop that hijacks that particular MIME type, you can view your location data over Google Earth spatial geometry. We've exposed these alternate representations in such a way that they constitute a read-only open application programming interface that conforms to the web architectural style known as REST, that is, representational state transfer. We use a uniform method of constructing the corresponding URIs across the whole site, and you see that summarized here. You can discover all of these resources. Oh, I'm in Chrome, aren't I? Different set of keystrokes. So you can discover these things, whoops, on the web by parsing the link elements that have the alternate value in the rel attribute out of the HTML. You can also use HTTP content negotiation to get at them in Pleiades. And the whole idea here is to make Pleiades an easy resource to reuse from other web applications. We also publish RDF versions of the content, and that makes Pleiades a linked open data application. We're proud of the fact that Pleiades was the first ancient history website or web application to meet the criteria for addition to the linked open data cloud diagram, where you'll still find it today. But if you don't want to script a web app against Pleiades or set up a triple server and do all that sort of stuff, instead you'd like to download all our data to do things with on your own in your own applications or tools, we try to make that easy too. So we have a downloads page that you can get to, and there we provide access to regularly refreshed bulk exports of the published data in several formats. Our JSON exports are the comprehensive ones. So they provide every attribute of every published place, name, location, and connection. The other formats are abridged. So the comma separated values, KML, and so on. Every published object is represented, but only some of the commonly used attributes are provided in each. You can also get packaged copies of our data from various third-party repositories. I've listed some of that here. And there are also a couple of really cool derivative data sets that are built and maintained by our partners. So how does all this information get created and updated? Well, we have a Plone workflow for that. And I'm going to show you that very briefly. It looks like I've taken a little more time than expected, and Alec is probably getting itchy to do some talking here. So let me just do a real quick demo. I'm not quite sure how the time got away from me. Oh, I see what's happening. It has to do, I actually got good time. I was looking at the Zoom time instead of the clock time. I apologize for all the noise. All right, so authenticated users can add content, and we do that in a Plone-like way. I'm going to use a username that I have assigned that doesn't have any special privileges. And I can navigate to the places top folder, and I can add a new place in the way you'd expect to in Plone 4. And you get a form that lets you add stuff in. So let's say we were going to add Atlantis. menu, fill out the form. It's unlocated. We can have multiple types, so I can call it an island, a settlement, so on and so forth. I won't fill it all out. References, I'll show you how that works in a minute. We can add tags. I could credit or blame other people. And I even have a details and field, rich text field in which I can write a long essay about how awesome Atlantis was. Once I save that, we're going to start in our default workflow state, and that's drafting, so it is visible only to me and to super users, and I can continue to edit this. In particular, I can add locations. We have a form that lets you put in an OpenStreetMap ID and import the geometry from there, which is very handy for features that are extant and visible in the world today. We can also add names using the typical Plone manner by entering stuff and using combo boxes for our various vocabularies as we encounter them. So for example, we're not going to let people randomly enter and type the name of the language. We're going to control that so that we don't get typos and that sort of stuff. So that's the basic process for adding something. Once you are ready to have it reviewed by our editorial college, you submit it for review using the typical Plone workflow transition thing. We encourage people to write useful comments beyond initial revision, although in this case, I think I'm not going to bother. I submit it for review. Once I've done that, if I'm a regular user, you'll notice as I am logged in now, you'll notice that the edit option on this thing is gone. So we on moving to pending, we lock the content item for additional changes by the user who submitted it. That keeps us from multiple edits involving the editors and the user at the same time. If I were to log in as an editor, I could look at this and revise it, and in this particular case, send it back to myself as deficient in terms of its content. But that's the basic way we work with new items. And so we allow people to come along and add whole new places for consideration, or they can visit an existing place and add a name or a location using these same, or a connection, adding these same kind of button affordances, and then those get managed through the workflow process separately. Now, modifications to an existing resources are a different animal. We make heavy use of Plone iterate, and I'm going to find a particular example, and I'm going to go to another browser and log in as an editor. Oh, I was already logged in, but I've logged out. Nifty me. Okay, so I scouted out this particular place in advance. So this is a place called Igigli, which is located on the North African coast. And you'll see here under the names listing, let me blow that up just a little bit for small devices. We have a Latin form of the name, and then picked out in orange here, we have a Greek form of the name. That means that this has been added. And this, I'm showing you now, the editor's experience of these that have just been added. And I can go through this and approve it for publication. I promised you Plone app iterate, but in fact, I got lost in my notes. Here's Plone app iterate at work in Pleiades. Adesina is a entry in Plone in Pleiades that I'm going to go back to my other user because I don't want you to be forced to see the editorial view of all this. And Adesina, it's still got some raw data in it from when it was imported from the original Barrington Atlas data. It's had some modifications made since then, but we'd like to improve it. The way I do this as a user, I don't get to edit it live, right? This thing is locked for regular users to use. What I have to do is I have to use iterate to check out a working copy. So I've checked out a working copy of the place. You'll notice it's copy of in the URL stub. And then I can edit this in draft to make the changes I want. So I can modify, any component of the presentation. I can iterate on that and then save it in my draft working copy. Once I've got that the way I want it, I can submit it for review just the way I would something entirely new. And then back in the editor's view, suppose I'm doing my daily editing task. And I want to see what's waiting. I hope this is not an embarrassingly large number of items. No, it's not. Here's that Andesina entry that my alter ego submitted for review. I can look in the history to see what was said about it. And then I can move it on through the workflow process. But what I'd normally do if I think this is good to go is I would check it in. And we bring forward the check-in message from whatever the workflow transition message was. And now, thanks to that editorial action, that summary is live in the database and it replaces the published version, but the history will still give you the ability to see back what was done previously to this particular entry, all the way back to its original ingestion into the database in 2009. So I think we are now at the point where I should turn things over to Alec and drive the slides for him and see how we go.
Hi, everybody. I'm going to go really quickly here because we don't have a ton of time. Let's see if we can get the slides up again, Tom. I'm not seeing them. There we go. So as you probably understand from Tom's demo, Pleiades is a pretty complex system. In fact, it comprises 25 custom Python packages. That complexity can make upgrades really tricky, especially for a development team that came in unfamiliar with the original code base. So when we did the upgrade, we ran into various issues. We made some testing fixes, had to update a bunch of custom views and customizations of existing views, remove some dependencies on some old packages, removed various cruft from add-ons that had come and gone over time. And then we made a variety of performance improvements. If you saw Philip Bauer's talk yesterday, you'll probably recognize a number of the sort of performance gotchas that we were dealing with, in particular things like lacking no call statements on path expressions, which caused objects to be fully rendered while generating a template. There were also there was a bunch of kind of inline rendered JSON in head. Tom showed you those links to data in head, and a lot of those used to be full JSON that in some cases got very complex and was very hard to render. We moved that stuff to async, and that gave pretty large performance improvements. And then over time, we've also replaced AT Vocabulary Manager with Plone app registry-based vocabularies, which means fewer catalog queries, fewer object lookups, and some significant performance improvements. And then, as Tom mentioned, we implemented Ansible to ensure we had repeatable deployments and that the server wasn't a special snowflake, which is a term you might recognize from Calvin's AWS talk yesterday. Plone plays a big role in Pleiades, despite the fact that it's a very complex system that doesn't necessarily fit into traditional content management. You can see that it uses tons of features from Plone through Tom's demo. We've got content types with complex custom schemas, hierarchical content models, custom permissions and roles, custom workflows, and then a pretty heavy dependence on Plone app iterate for content content staging. The fact that iterate is based on adapters makes it really easy to customize the data copying and merging logic, which Pleiades does extensively. And then on top of that, we use custom views for the various non-HTML representations for exports, and we depend on a variety of Python libraries for doing that, some of which, as Tom mentioned, came directly out of this project. In terms of recent work that Jazkarta has been doing on Pleiades, we've been preparing for a while for a Plone 5 upgrade. We've made improvements to the bulk import process. We've completely eliminated AT Vocabulary Manager, improved the iterate customizations so that checkout check-in process works pretty seamlessly. Made completely comprehensive JSON representations, improved this concept of promoting locations to places, which is something the demo didn't quite get into, but it's another kind of workflow-y action that allows you to actually kind of convert subordinate content types into places. And then a bunch of other stuff, including better mapping systems and updated geographic information. Eventually, we do plan to move to Plone 5.2 and Python 3, but the whole site's done in archetypes now, so we're going to have to move everything to Dexterity, including all of the kind of connections and relations, the various data. There's going to be a bunch of custom behaviors because there's a lot of sort of shared functionality in terms of bibliographic references and things like that. All the custom views are going to need to be updated. So our plan is to basically do a new updated implementation of the site in Dexterity, test everything out, leverage the fact that the site already has a comprehensive JSON export and a bulk import update feature to do the migration. And for non-custom content, we would just use collected JSONify and transmogrifier. I'm not sure that this site is a good fit for Volto at this point. As you saw from Tom's demo, it's really a data-driven research tool. So the need for customizable layouts and the other kind of nifty things you get with Volto is pretty minimal at this point. But who knows? You know, that's the future. Anyway, that's it from me. Thank you, everybody, for coming to this talk. And thank you, Tom, for that wonderful demo.
Yeah, thanks from me, too, to everybody, and to you, too, Alec.
Hey, great. Thanks, guys. That was fascinating. It's really cool to see how much work and all the cool stuff you can do with the Plone site, and especially in the context of this. So we have one Slido question from Philip, and that's, what do you use to replace AT Vocabulary Manager? Is it collective taxonomy?
No, it's essentially just a custom Plone app registry set of vocabularies, a couple custom classes that pull vocabularies out. And then in the case of Pleiades, there's a view that makes those vocabularies appear as sort of content-ish things to make it
we didn't
the same
demo
as
that.
ATVM. Yeah. But yeah, it's custom code. There's an add-on. All of these add-ons are actually open source. I'm not sure how useful they are to anybody outside of Pleiades, but Pleiades vocabularies add-on has all that code in it, and it used to all be ATVM in there, and now it's the new stuff.